Hey guys, today we are going to have a short discussion about this problem. So it's also a 1900 problem. Um, so as always, we are going to start with the example here. So in the input, we are going to have first two numbers, and the first number telling us how many L ports and how many paper factory are there in our problem. So in this case, we have three factories and three airports, right? Um, and then we are going to have five edges connecting those factories and airports. And this is the description of those edges. So this is the starting point, which is a factory, and this is the ending point, which is a airport. And this is the cost of the connection, right? So this edge means it starts from the first factory and ends at the second airport, and its cost is 1. So our job is to find a match for these two sets. And we need to make sure that all of those factories and airports has exactly one match, and one airport only matches to one factory, and vice versa, right? And we need to find the match that the maximal cost is the minimal, right? For example, for this graph, we are going to choose this connection. Let's change the color here. We are going to choose this connection, which cost 1, right? And choose this connection, which cost 4, right? And choose this connection, which cost 3. So the maximal cost is 4 here. So we output 4. So let's try another selection. If we choose, let's say, if we choose this guy, actually, that's the only selection we can choose from, right? And it is the minimal. So we output that number, right? So how can we find the minimal cost selection? So we are going to use binary search. So we are going to search from 1 to 10 to the power of 9, right? And search in this range and find the minimal cost of the selection. And for example, if we choose 3 as the minimum cost, we're going to remove those edges that the cost is greater than 3, right? We're going to remove this one and remove this one. And after we doing that, we only have 3 edges for select, right? And we cannot find a perfect match for these two sets by using only these 3 connections. So that means this minimal cost is not viable, right? And we are going to choose a bigger one, right? For example, 4. If we choose 4 here, we are going to remove only one edge, which is this one. This one is 5, bigger than 4, right? And the rest of the edges can be selected for a perfect match, right? So 4 is the output here. So with the binary search, all the rest of the problem is to find if the rest of the edge can be constructed as a perfect match between these two sets. How can we know that? So um, we are going to use a template here, which is Hopcroft-Karp algorithm, right? This algorithm is to find the maximal match between two biparty sets, right? So essentially, um, let's take a look at the input and the output of this algorithm. So it's really simple. So we are going to construct this graph, right? So this is the left side points, right? So in our case, there are three points in the left side, right? And the second number is the number of points in the right side. And we are going to add all those edges to the graph, right? The left number is the starting index, and the right number is the ending index for the edge, right? After we add all those edges, we're going to call this API. So it returns the maximum number of matches. So in our case, if we are going to input n and n here, two n's, because we have equal number of output and factories, right? And if the return number of the maximum matching is equal to n, then it means that we can find a perfect match for the given edges. So that solves our problem, right? So let's take a look at our code here. So this is our main program. The rest of the code is just a template. We can just copy paste from the algorithm here, right? And so first we're going to read n and m. N is the number of factories and the outputs. M is the number of edges. And we are going to record all of those edges, right? And we are going to use binary search for the minimal cost of all the maximal edges, right? And this is the part we are implementing the binary search. And this part is to check with the current set of edges, can we create a perfect match for these two sets, right? And the checking part is to first construct the graph by using the edges that is smaller than the given maximal cost, right? And we are going to add those edges into the graph. And we run the Hopcroft-Karp algorithm and find out if the maximal match is equal to n. And if it is equal to n, that means we can find a perfect match with the given edges. And we can continue the binary search. And we are going to find the minimal maximal cost, right? And we are going to output it. So that's it. That's how we solve this problem. See you next time.